All right. So free software cutting me off and stuff. So, anyways, this is your regression equation. You have your intercept A, your slope B, and then your value of x, which is what you're going to predict for y using some value of x. So first, we want to calculate this B, given correlation of xy times standard deviation of y divided by the standard deviation x. As an example, in the problem given, this is your equation. You get that value. Do the next part, plug in that value you got from the previous part using this equation, calculate that, you get this value, and of course you finally get your prediction right here by plugging in 21, and you get the score of 2.5. So if you look at that, that would be your, if you look back at the original quiz question, I plugged in 21 because that was what they given you, and you're supposed to estimate the y, so you get 2.5. So remember that what determines x and y is what the question is asking. So what would we predict Mr. Big's first year GPA to be? So GPA is your prediction variable, and that is therefore your y. If you ask the opposite question and give a different score here, your GPA, then your ACT would be your y. So correlation describes the direction and strength, positive, negative, and how close it is to 1. So don't get confused between correlation and the relative risk index or the ratio. Correlation between x and y value has a 0. This means that the slope of the regression line is 0. You can have a significant relationship even though the value is 0. It doesn't really say anything about the variance, so this is your most correct answer. Evidence for causation is difficult to determine without experimentation. It's the best way to show that A causes B because you control for all the other random or confounding variables. So of course, not confounding because confounding makes things worse. Correlation does not equal causation, so that's off too. Observation, cool. You're looking at things, but it doesn't tell you why things really happen. You have to determine if that's what caused it. So this one, Dr. Vickman determines that people with high satisfaction and very low satisfaction tend to perform low on the end of the course knowledge test. So that is a significant association. What's the best estimate for the correlation between satisfaction and knowledge test scores? The issue here is that it's very high and very low, right? And what we learned about outliers and all that is it kind of skews data. You have them on both ends, then the correlation is going to be 0 because they're balancing each other out. But it's predictive, but it's not it's going to be weird for that one. But if you have two ends of the spectrum, the answer is going to be closer to 0 for that prediction. So Josh has noticed the more coffee he drinks, the more he finds the jokes as funny. This is asking you about assuming there is no evidence of coffee consumption causes funniness ratings. There's no association. Which of the following would be an example of a common response explanation of this relationship? So a lurking variable, essentially. And so the answer is just he is sleep deprived. This one's kind of like a logic thinking question, and you have to determine which one sounds the most correct. So that's one of the harder ones to really say much about. The next question, decided to set up a survey on MySpace, reported hours of usage and raters of quality of users' relationship with school friends, indicated that those who spent more time on Facebook had a lower quality relationship with their friends from school. Best described as a negative association because they spent more time, so that's increasing, and they got lower quality relationships, so that's decreasing. So when you have if you can imagine, John, that's the grid. You can see my mouse, the grid. Basically, as one number increases, the other one decreases, so the line is going down. Question 8. Tall men tend to marry women who are taller than them on average, but the degree of association is not too strong. Which of the following best describes the association? Well, we know it's positive, because they say that. So the degree of association is not strong. Tells you the value should not be that different from 0. and tall men tend to marry taller women on average, so that's a positive rather than negative. So the closest answer would be plus 0.2. Which study is famous as a precautionary tale against drawing a conclusion based on aggregated data? The Berkeley study, as I mentioned at the start of this video or the previous video, is the one about discrimination against women in graduate studies. That they found out that department-wise, as a college, it was shown a discrimination, but when they looked at different departments, they showed that all the departments were actually accepting more women. And so that's an example of ecological fallacy. A regression line is a straight line that describes how a response variable changes as an explanatory variable changes. So as one variable changes, the other one changes in a certain way, and that regression line basically tells you their relationship and their predicted relationship. Doesn't tell you the opposite. Doesn't talk about any lurking variable changes. And then categorical variable changes would be like male, female, and they don't really make sense because, yeah, it would be a completely different grouping, so that is not represented on a XY plot. And so that concludes the video. And so good luck on your real exam.